This is Embedded FM. I'm Alicia White alongside Christopher White. We're going to talk about Linux kernel hacking today. Yes, you heard me right. Kernel tools and how they make your application development better. Julia Evans is here to help us because you all know how I feel about operating systems, even RTOSes. One thing first, our multimedia empire is growing. Please check out our blog at embedded.fm/blog. It's cleverly hidden that way. I put in a second entry about taking toys apart. Andrei Chitak and Chris Sveck continued their respective introduction to embedded systems. And Christopher White unboxed the Particles cell modem platform, the Electron. So RSS should work. If you have trouble, let us know. And I will get a newsletter together very soon. Okay, now on to Julia.
Hi, Julia. Thanks for joining us this evening.
Hey, thanks for having me.
Could you tell us about yourself?
Yeah. So I have been a software developer for a while. And at some point I got really excited about operating systems, and I decided that I wanted to learn way more about them. So I started a blog where I write about things that I don't know about, and then eventually I learn about them, and then I tell other people what I learned yesterday.
It's instructive to hear what problems you're having as you're having them.
Yeah.
One of the things that you write about a lot in your blog is strace.
Yeah. strace is my favorite program in the universe.
That's a little odd, right? I mean, you recognize it's a little odd?
No, it seems really normal to me.
Okay. Yes, and Christopher's reminding me that I forgot a whole section here that always goes at the top. You'd think I would learn this. We've got to do lightning round. Okay. So lightning round is where we ask you questions and look for one-word answers. You don't have to explain, probably, unless we really want you to. But
it's usually better when you disobey that, though.
Yeah, that's true. Okay, Chris, do you have one?
All right. Let's start off with what programming language do you think should be taught in the first CS course?
Python?
What is your favorite programming language?
No.
No?
I don't have one.
Okay, that's fine. Okay.
I wasn't sure if no was a new one, because I've been losing track.
I was like, Go, Rust, no? Sure, that totally
I would program in no a lot, I think.
I think no is the best programming language.
Favorite fictional robot?
Oh, man. I wasn't prepared for this.
That's fine.
You can pass.
There's a robot, but I can't remember its name.
Okay.
It's from... Anyway, no, there's a science fiction story which I love.
Tell us.
I can't tell you anything about it. What is it about? It's about these robots with feelings. Anyway. No,
okay.
That's not nearly enough, but okay.
Yeah.
Have you seen the new Star Wars movie?
No, I have not.
Dogs or cats?
Cats.
What is your second favorite operating system?
OS 10.
What is the worst version control system you've ever used?
I like that.
None. Not using version control.
Okay. Yeah, that's actually the perfect answer.
But it's too perfect. Well. Someday somebody's going to say git, and I'm going to ring a bell, and balloons will fall from the sky and all of that. What kind of phone do you have?
I have a Android phone with a broken screen.
Very popular model, yes.
Favorite planet?
Earth.
Oh, I guess that's the right answer.
She's good at this, but she chooses answers I wouldn't expect. I don't even think Earth is on the list.
It's not.
Which came first, the chicken or the egg?
What?
The chicken?
I agree with that. Hacking or engineering?
Oh, goodness. It depends if I'm being paid or not.
Yeah. Favorite conference to speak at?
Bang Bang Con.
What is Bang Bang Con?
Bang Bang Con is a conference about the delight and wonder of programming, where all the talks are 10 minutes long. And the only rule is you have to have an exclamation mark in the title.
New York City in May. All right.
Yeah, the CFP is open right now.
I'll add a link to that in the show notes. 10 minutes isn't a lot to prepare for.
Yeah.
In 10 minutes, I could lie about anything.
Yeah, exactly. 10 minutes, I could talk about nothing for sure.
That's kind of what I meant.
I saw a video of you speaking at PyCon in 2015, where you did not, in fact, speak about Python at all. What did you talk about?
So I talked about how, like, understanding your operating systems better can help make you a better programmer. And the way I kind of approached it was I was like, well, suppose you have some Python programs, and they're slow for some reason, and you want to find out why without actually knowing Python or without like interacting with Python in any way. And it turns out that you can totally do that. Because, so for example, one of the programs was slow because it was like waiting on a really slow network connection, right? Like the server on the other end was just doing like a sleep 10, and it was like, I'm just going to wait 10 seconds and do nothing and not reply to you. And if you look at, like, if you ask the operating system what the program is doing, it's like, well, it's waiting. And you're like, well, what is it waiting for? And you can kind of find out that it's waiting for a network connection without actually knowing that Python was doing that at all. So I wanted to introduce people to those tools because I think it's really important to know.
Well, one of the things you said that really caught my attention was debugging applications as though they're black boxes and you can't look inside of them.
Yeah, right, exactly. And one of the reasons I like that so much, like treating your applications like a black box, is because, like, when you write a program, you've always kind of done something that you didn't expect, right? Like, so you might as well assume that the person who wrote the program is like malevolent and is trying to trick you. So if you like ignore the source code and just like observe what the program is doing without like making a lot of assumptions about what you think it's doing, you can sometimes get a lot further in debugging it.
And so do you use this on your own code, or is it mostly looking at other people's things and why they're not running as you'd expect?
Definitely both. Like, I use it a lot on my own code because when I'm debugging it, it means kind of by definition it's doing something I didn't expect. So I try to just go look at what it's doing. And yeah, like kind of pretend that the source code isn't there.
And you usually run in a Linux system.
That's right.
And so all our conversation today is going to be more about Linux. And for the most part, the show tends to avoid operating systems. But many of these same tools exist in other operating systems.
Some of them do. I mean, so if you're debugging a program by asking your operating system what that program is doing, that's kind of like the definition of like an operating system specific method, right? So a lot of the tools that I've learned about are like only for Linux or only for OS X.
And that makes sense. And so that brings us back to strace.
Yeah.
What, assuming I have never seen it before, what does strace do and why would I want to see it?
Traces S's.
I know big S's on the screen.
Yeah. So to understand what strace does, we can talk about what a system call is, which I'm sure you both know. But should I explain what a system call is?
Yeah, go ahead. I mean...
Yeah, a lot of the people who listen to the show don't use operating systems that much, or at least high-level ones, so it might be a good thing to go over.
Awesome. Cool. So if you're using an operating system, I guess this is kind of like more obvious if you think about it from an embedded point of view, because like normally you don't have an operating system, so you have no way of doing things like sending data over a network, right? Like you don't expect to be able to easily send data over a network. Is that right?
We can, but easily is probably the key word there.
Right.
I mean, you're doing in an embedded system without an operating system. You're doing a lot of these things by hand.
You may not be. Yeah, you
Right.
probably aren't granted, a socket interface normally or something like that.
That'd be nice.
Yeah, because I think like people who write like desktop software or whatever are just like, oh, I can just send information over a network. There's no problem, right?
Right.
But then if you're an embedded developer, it's like much more immediately obvious to you that there is a problem. So a system call is just like the operating system has all this code in it to do things like, like do networking or like write files to the disk or
Scheduling.
Yeah. And a system call is just a way of like asking the operating system to do that, right? So there's like one for reading, one for writing, one for opening a socket or like sending information over that socket. And strace just tells you what every system call your program is using is.
So if I write program, I don't know, foo, I can strace foo. This isn't like top where I get straces of everything that's running.
Right. Yeah. You just get foo.
Okay. And so I strace foo, and then foo like has an infinite loop or something, and strace would tell me I was stuck in my while waiting for file ready loop.
Right. So if I had if you just had an infinite loop that was like while true, repeat, strace actually wouldn't tell you anything. Because there you're just running like instructions and you're not talking to the operating system.
Right. There's no system call there.
Yeah, because there's no system calls. But if you had if you were like pulling a file, then it would tell you like if you were like pulling whether or not a file existed every second, then every second strace would print like you tried to check if that file was like you ran like fstat or whatever every second.
Doesn't that usually give you like a giant wall of text? The advantage to having an operating system is you get to call all these things. Wouldn't it be too big?
So it turns out that it's not always too big. So this is what I think is amazing about strace. I can tell you an example from the train once, because sometimes when I'm on a train or on a plane, I'll just like strace things for fun and see what happens.
Doesn't everybody?
Hopefully not things running on the plane.
Strace navigation.
I'm not that kind of hacker. Right. So there's the kill program on Linux, which like will kill a program. Like you're like. So I wanted to know how it worked, and I think I actually wanted to know how pkill worked. So pkill is this thing where you're like pkill Firefox and it'll find all the processes named Firefox and it'll kill them all. So I wanted to know how this worked. And I was like, well, what if I just ask strace how it works? So I straced it. And then what you see when you strace is it opens every single... so in Linux, on Linux, processes each have a PID, and those correspond to a directory in /proc. So like /proc, /5, /whatever. And so it opened every single like directory in /proc. And then you could see sometimes it would like, so it would like open it, move on, open one, move on, open one, move on. And then every so often it would kill one, right? So it'd be like open, read, kill. Open, kill. So you can see what it's doing is it's just going through these files and opening them and then finding out like if that process is called Firefox, and then it kills one once it finds the right one.
Sort of like playing Duck, Duck, Goose.
Yeah, kind of. And then you can see like exactly what it's doing from the system calls.
That makes sense, and it seems like it would help with debugging. Mm-hmm. But you really like strace.
I do really like strace.
And you like oscilloscopes. It's an operating system oscilloscope.
That it is. It is, in fact, that. Okay. So can you give me one example you used in your talk was about figuring out which configuration file Chrome opened, which is interesting to me because I can never figure out which fig file is currently trashing my build.
Right.
How do you do that?
So what you do, I did this today, actually, because I edited a file and I couldn't remember which file I edited. So you run strace, you tell it to look for the open system call. So look at when it's opening a file. And so if I strace Google Chrome and ask it for every file it's opened, then I can find all of Google Chrome's configuration files because it needs to open them all. And that's it. And it can't like lie to you, right? Like documentation can.
That seems like cheating.
Yeah.
All right. I have no problem with cheating if it helps you get your job done better. One of the other tools you talked about was perf, which is one I'm a little more familiar with. But can you explain perf?
Yeah, but I really want to know how you use perf.
I use perf a lot like I use top, which is to say I use it to figure out what is currently using too much of my processor. Do
you use perf top?
No.
I just learned about perf top, which is why I asked that.
Okay, good. I didn't know if I was using the wrong thing all the time. Okay, so tell us about perf and then perf top.
Yeah. So perf is kind of complicated. So actually I want to talk about perf top first because it's my current favorite thing. So perf top, so top tells you like which programs are running on your computer. And perf top tells you which like C functions basically are currently being used the most. And I was kind of surprised at how useful this is. So I was on a machine the other day, which was super, super slow. And I wanted to know what it was doing, right? Like it was spending all of its time on the CPU. And I was like, what are you even doing, program? This is dumb. And so I looked at it and it was a node program. And like every single function that it was spending the most time in was like looked like garbage collection. It was like mark and sweep. And I was like, I know what mark and sweep is. It means like garbage collection. So then I could see like instantly that that entire machine was busy because it was spending all of its time garbage collecting.
So doesn't that require the symbols to be built with the, I mean, if you have an executable that's stripped, can it tell you anything?
All system calls?
Well, that was strace, but perftop tells you.
Yeah, perftop is about C functions. So yeah, you're totally right. Like that can be a problem.
Okay.
Yeah. But often it's not. So you just kind of try it out and see if you get lucky.
But if I wanted to prevent you from looking, that would be the thing to
do. Yeah, you totally could.
Which I guess if you were debugging your own code,
yeah,
that would be less useful. Okay, so perftop tells you all of the C functions that are most in use. So if you're like if you did perftop on the pkill app that we just talked about, the pkill executable, it would tell you that you used open a lot. fopen.
Yeah. Well, it might not. So, because perf is all about CPU time. So, and like a system call like open isn't really that expensive in terms of CPU time. So it might not think that that was very important.
So if you wrote a dumb version of pkill that every time you opened a file, you read the whole thing, then you might start getting, well, okay, I can totally design bad programs. I'm good at that.
Yeah, but no, that's totally right. And there you would probably end up seeing, well, yeah. Like if you read the whole thing and then like iterated through the file like 10 times, yeah, you would probably see something to do with that. But you might end up seeing it being like some kind of string function, right?
Yeah.
Yeah.
And so perftop, okay, how is perf different?
So perf has like a bunch of subcommands in it basically. And top is one of them. So another thing you can do with perf is annotate like assembly code, which was really surprising to me. So like I at some point tried to write a program that was fast. And I wanted to see like how many bytes I could add up in a second. So I had like a 6 gigabyte file and I was like, can I add up like all 6 gigabytes in a second? Like, or not? And the answer turned out to be yes, you can totally add up 6 gigabytes in a second, which was a little bit surprising to me because 6 gigabytes is sort of a lot and a second is like not that much time. Anyway, but so I like wrote a C program to do it and then I compiled it and then I was like, perf, which instructions did that program spend the most time on? And then it could totally tell me, which was very surprising to me.
It's a performance analyzer. Christopher's looking at me like,
well, I'm wondering how I know how profilers tend to work in IDEs, and I know how strace works, but this is just something that attaches to any running executable. So I'm curious how it's doing its job.
Well, either it is statistical sampling, where it is running and then every tiny increment it interrupts and goes and it looks at the program counter. And then over time, it just ticks which program counters. It finds what function your program counter is in. And then it will just, plus to that function. And then you get a statistical sampling of what you're doing. And I guess I could look on the Wikipedia page.
No, but that sounds like a plausible answer.
Yeah, that sounds totally right to me.
Yeah, it's statistical profiling of the entire system. And it does support hardware performance counters, which means it also supports the other way of doing performance, which is to put little breaks in and say,
right. That's what I was wondering.
Did you go through here?
Right.
And that way you have to support it more on the code, whereas statistical, you don't. But it is interrupting your program all the time, which has some runtime effects.
Right.
Yeah.
Right. I doubt you added up the 6 gigabytes while perf was running in a second.
I did.
Oh, it did?
Yeah.
Wow.
So perf is actually pretty low overhead, which is the amazing and wonderful thing about it.
It uses more RAM, but it doesn't use much processor because it just goes in, gets the program counter, goes right back out.
Yeah.
It's a fast interrupt.
Yeah. I'm still a little unclear on the mechanism. Like, I know that, it's something in the Linux kernel, right? Which, lets perf work.
Okay.
Yeah. It wouldn't work unless something inside the Linux kernel was, cooperating with it, I'm pretty sure.
And you mentioned that if you didn't hook in your symbols, perf would be pretty boring because it would just go to each instruction line. It would be each program counter that it outputted.
Right. It would still give you, now that I understand how it probably works, it would still give you some output, which you could use if you were reverse engineering still. You'd say, okay, it's at this address a lot. Let's go look at the disassembly and see what that might be doing. Yeah,
because you don't need to look at the disassembly when it isn't running those instructions very often.
Right.
Look at the good stuff. So have you seen instances where perf or strace or perftop cause problems as you're debugging? I mean, the tool gets in the way of the issue?
That's a fantastic question. So I haven't seen any problems with perf. My impressions of perf so far is that it seems really low overhead. I'd run it on stuff. There's no problem. strace is totally different. strace can slow down your program by 50 times if it has a lot of system calls.
And that makes sense. I mean, if you put a gatekeeper into your system and he has to do that thing where you punch the button that says click, 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 that takes time. Even if it seems fast, if you're doing it a lot, it takes time.
And this isn't a fundamental necessity. So there's a program called dtrace on OS 10, which you might know about, that can do basically exactly the same thing as strace, except it doesn't slow it down that much.
Yeah, they have something called instruments too, which is a GUI thing on top of it, I think. And
that's totally right.
Probe all kinds of activity.
Well, and then and then there's one more tool that I wanted to talk about, and that was Top, because that one, if people don't know about, it's super useful. And that is, I mean, if you were in Windows, that would be your resource monitor. What is it in Macworld?
Top.
Oh, that's true.
On the command line.
On the command line. But it just shows you what processors are using the most CPU, the most RAM, the most, networking. And so it's super useful for all of the same reasons to figure out which of your mini programs is causing the biggest problem. I don't know, I was headed off into, if you were using embedded Linux, these are the tools you want to make it tiny and power efficient.
Yeah. Yeah, especially since if you're doing embedded development, usually you own the whole stack, right? Or you have no operating system and you've written everything, you know what's running at all times because you've written it all. Whereas if you shift to embedded Linux or some larger operating system than just an RTOS, you have a lot of stuff running that you may not know is there. And so the performance of your system and the battery performance and all that kind of thing can be a little bit out of your hands. So
I was surprised with one of my embedded Linux projects. It was going out to update a program that I thought I had deleted. It wasn't even that it was trying to run the program. It just was trying to run its little updater. And I was like, this is not a good use of your network. You don't have any network, cut it out. But I wouldn't have known that without knowing some of the tools. That was just top, so I'm really good with that one. Okay, so that's sort of why benchmarking matters in embedded systems. But you don't work in embedded systems. You work on larger things. You work on web stuff.
Yeah.
And I know you didn't want to talk about your job in particular. I just kind of wanted to settle where your code normally runs.
So it normally runs on like Linux servers that are connected to the internet. So like web stuff.
And so why does benchmarking matter to you?
So sometimes I have programs that are too slow, right? Like, I need to handle like a certain number of requests per second, and sometimes my machine is like not doing it, and I need to know why.
Requests per second. Okay, I mean, it just totally changed subjects here. I was curious, so I wanted to ask more about. You have a blog post where you talk about requests per second, and you call them QPSs.
Oh, like queries per second. It's the same thing.
Okay. So you also gave a talk about this topic about how computers are really fast, but only if you use them right.
Yeah. And I think this is like much more obvious to people who do embedded programming, because like you have like such a small computer and then you need to make the most out of it. Is that right?
Oh yeah. Oh yeah. Well, and that's sort of where I was headed. When in that post you talked about languages and QPSs.
Yeah. Right. So like I guess I kind of, because I think it becomes like not obvious when you're using like a large computer how fast it is at some point. Because like if you're writing, I was talking to someone who was generating a blog using Ruby, and like you can see these posts where someone is like, I'm trying to generate some HTML files and it takes like 2 minutes. And my reaction to that is like 2 minutes is a disaster, right? Like you're just like generating some HTML. It should not take 2 minutes. But it's not, I think, always obvious to people who I think especially like get further away from their computers and aren't doing things like embedded development where they think about like the cost of everything really carefully, how like fast the computer is actually supposed to be, if that makes sense.
Oh yeah, it totally makes sense, because what I will totally not put up with for my device, I will, on the other hand, let Windows do its stupid updates and let it take like 30 minutes. I would never let my device do that nonsense on power off.
Right,
but
exactly.
I'm locked into this. This is what it does, and Chrome is sometimes slow, and if I have all 15 programs I usually running at the same time, everything gets slow.
Yeah.
Chris is looking at me like, I'm never helping you with your computer again.
Yeah. But like our programs that we write don't need to be slow, right? Like Chrome can be slow, but not my program.
One of the things you talked about was comparing languages. And
yeah,
I was fascinated by this because we've been talking a lot here and on the blog about languages and choosing and how to decide.
Okay. Yeah. So I wanted to get some like really ballpark estimates of like how fast each programming language is, even though it's like kind of a nonsense question, right? Because like, of course, you're going to have like different workloads, and you're going to be doing different things depending on the language. But I was like, okay, let's say you're trying to serve HTTP requests, because I work on like web software, and I need to like serve requests. And a kind of like natural thing to talk about to me is like, how many requests can you serve in a second, right? And so I started like Googling this, and it turns out that in C, you can serve like 5 million requests per second, which when I first learned this, I thought it was like a joke or like a typo. Like I didn't realize that you could do that. Like 1 million is like really a lot. And it turns out that in Java, I think you can also basically like serve a million requests per second, which was also kind of like fascinating and surprising to me, because I was like, I thought Java was slow, but Java is not slow at all.
Oh, in your blog, you have Java at 50,000 and C at 1 million.
Yeah, so that was kind of like, I didn't want, like, I think you can do 1 million, or like almost 1 million. I wrote 50,000 because I was like, it's definitely at least 50,000. But Java is like quite fast, like not a lot slower than C.
Which is surprising. Most people wouldn't think that. I mean,
yeah,
most people in this room wouldn't think that at all.
Java outside of probably the people who use it a lot does not have a reputation for speed.
Yeah,
but once you get the just-in-time compiling down, it can get fast, especially if you're doing something in the Java frameworks that gets more optimized. Okay, but the other one you had on your blog post was Python.
Oh yeah, right. So I was like, okay, C and Java are like fast programming languages, and Python is like not. Python is not the same, right? Because with Java, you can write your Java code and it can get like just-in-time files, so like assembly, and then that's super fast and that's awesome. But Python is an interpreted language, so it's definitely going to be way slower. But so I found a benchmark, and I was like, okay, Python can totally do like 10,000 requests per second, which is still like quite a lot, right? Like most websites don't need anything faster than that.
But orders of magnitude.
Yeah. But it's like a lot slower, but still like way faster than like than you might think, right? Because if you think like Python is slow, you're like, oh, does slow mean that it can do like 5 requests in a second? But it turns out that it means you can actually still do like tons.
So in the beginning of the show, in Lightning Round, you didn't have a favorite programming language. With this, it seems like you should. I mean, C and Java are a lot faster than Python. We've established that for sure now, in a line in the sand.
Yeah. I don't... So, like, I really like knowing how things work. And part of the reason I find performance really interesting is because it gets you into like really interesting questions about like how things work. And if you ask why something is slow, like the answer can turn out to be very interesting. And like very surprising. Mm-hmm. But I don't really care about programming languages very much. Like I care about programming, and I like to do things, and I like to understand how things work. And I like to understand how things work in every programming language, but I don't, like, it's not very important to me.
I get that.
Yeah.
No, I totally get that,
I get
because that. I feel that way sometimes too, that people get so worked up about this language or that language or what's new. And I do feel like once you understand fundamental programming concepts, you know, they all have their pluses and minuses. And
mm-hmm.
I would not do, I mean, I've used NumPy and I've used MATLAB, and they're both interpreted, and I would not do visualization in C. Not unless it had to be super fast. I mean, it's just so much easier to program those in Python.
Yeah.
So languages all have good pluses and minuses. So.
Totally. Yeah. Like if I'm doing machine learning, I'll use Python, and that's it, right? Like Python has like awesome like machine learning libraries. It's really good at scientific computing, and I would just use Python all day. Like, and I would never consider using anything else.
Because your time, I mean, even if you're running something that takes hours, you would rather it ran for those hours than you put in the 6 weeks it would take to make it faster.
Yeah. Yeah. And also, like, it's already quite fast. Like,
wait a minute. Stop. We're getting lots of noise.
Uh-oh. Okay. How is it now?
It's perfect now.
Oh, cool. Okay. I just, like, won't move at all.
Sorry. Yeah.
Sorry. I'd prefer tapping to that.
Okay. Well, yeah. We'll see what happens.
Okay. Christopher, will you cue us back?
Cue you back what?
Oh, I missed some of what... Julia, do you remember what you were saying, or do you want to go back?
I don't know what I was saying.
I can play it back.
With NumPy and Python, NumPy is already super fast.
Yeah. So it's funny that you don't have a strong preference about language, but you do have a really strong preference about tools. It's a different take, and I like that. But how did you fall in love with strace? How did you get how did you get this perspective that you wanted to get more into the tools?
So the reason I find these tools exciting is that I feel like they're a lot, like learning about them is a lot higher like leverage for me than learning, for example, a new programming language. Because if I learn more about operating systems, every program I write has to interact with my operating system. So anything I learn about operating systems will help me like in all of my programming. Whereas if I just learn something about Ruby, it'll only help me when I'm writing Ruby.
And sometimes learning one tool very well, it leads to using that tool for different solutions, your deep understanding. I mean, I guess it's sort of I have a hammer, look at all the nails.
Yeah, exactly.
But how did you choose which tools to dig into? Why these?
Why strace?
Are there any that you've thrown away?
Yeah, ones you got interested in and then decided, oh, I'm not sure LS has all of the features I want.
Yeah. So yeah, like I have a kind of a research list of tools in my head that I'm trying to learn about. And most of the ones that I don't end up learning about are like many of them are very complicated or seem like difficult to me. So there's this thing called ftrace, which is a way to trace function calls inside the Linux kernel, which I think is really powerful, but it also has like a fairly difficult interface. And so I haven't like gotten into it yet. But strace, like the reason I love strace is because its interface is so simple, right? And like the contract it provides is really simple. Like it's just like, I'm going to tell you system calls and only system calls. And so you know exactly what you're going to get. And what you get is like pretty straightforward. And then it ends up being useful. So I guess I like things which are like relatively simple and also like where the information they're giving you is like very useful.
And that makes sense. One of the things you've talked about on your blog and in various talks is that you are sort of a beginner. You come at this from a beginner perspective, even if you are no longer a beginner. You're still in that mindset of learning. But for many people, it's a very chicken and egg problem where you need to have enough breadth to know which tools are interesting and then immediately go into the depth of that tool, which means that, again, you might spend 6 weeks learning all of the command line variations for directory printing.
Right. So I think this is a super interesting question. Like how do you learn something when you're like a beginner at it?
And how do you balance it? Yeah.
Yeah. So the way I've kind of approached this, like for better or for worse, is I just like I spend like a fair amount of time like learning about these tools, like just for fun. So I'll just like strace things and see what happens. And then I'm not like there's no pressure that like I need to debug this thing right now. I'll be like, oh, what happens if I strace this? Or like, can I debug this with the strace? And maybe the first 10 times the answer is no, right? And like I'll strace it and I'll be like, I have no idea what that meant at all. Okay, well, next, right? And I find like just like trying a tool over and over and over again without too much like expectation about whether or not it's going to teach me something.
Practicing.
Yeah. Yeah.
I mean, mindful practicing, that's trying it out, experimenting. Yeah, okay. But how do you choose which ones? Are there books or blogs or tutorials that you go to first? I mean, do you hit the man page?
I almost never read man pages.
Man pages are for wimps.
People tell me things. Like the way I learned about strace is I was asking a question or I was just like talking on the internet about something that I didn't understand. And someone was like, have you tried strace? And I was like, what's strace? And then it totally solved my problem. So this is kind of a weird thing. Like, but yeah, like sometimes I'll be like, I'll talk on my blog about something, or I'll like talk on Twitter about something that I'm confused about or that I'm learning. And then people will just like email me and tell me about a new tool, or they'll like tweet at me.
This actually is the beautiful thing about Twitter and even blogs. I mean, we're already getting comments and it's been exciting there for us.
Mm-hmm.
When you go to your blog and try to write these things up, even as you're struggling with them, you tend to try to make it easy. You make the technical topics easier for people coming into it and really do a good job of explaining the groundwork. Why do you do that?
I kind of can't imagine doing anything else. Like, I think that things should be made as easy as they can be made. Yeah. Like, yeah, I don't know. Like, often I watch talks and someone is explaining something and they make it sound really complicated. And I'm like, that's not that complicated. You could explain that in an easier way. Like,
so
yeah.
how do you figure out how to explain it in an easier way?
So a lot of the things on my blog, I tried to just explain to myself, like last week. So like, because I write out things as I'm learning them. So I'm like, okay, this is what I knew last week. And this is what I know now. And then I try to just like cover the things in between. So that Julia last week would have understood.
Yes, that's a very, very reasonable way to do it. I often say I am writing for me in the future a year when I'm doing documentation on my code. Because future me isn't dumb, but she's totally forgotten everything about this.
Yeah.
So writing for a week ago you makes a lot of sense. And when I worked on my book, I was writing for me, but years ago.
Yeah.
College grad me. Do you have advice for debugging?
Oh, yeah. So I wrote this blog post about this, which I really like. Not really advice, but more like things that made me better at debugging. Because I used to really be really bad at debugging, I think. Like, I would have bugs in my program, and I would just, like, be sad, and I was like, this sucks. Why does my program not work? This is not fun. I just want it to work. And
the
now
frustration and the anger and the horror and the fear that people are going to find out that this is all that you are. Yeah, I'm familiar with these things. Go ahead.
Yeah. And now I really like it. And I was thinking about, like, why do I like debugging now? Why did I hate it before? And, like, to me, one of the scariest things about debugging is this fear that, like, you're never going to find a bug and it's going to be there forever.
Every day. Oops. Did I say that out
loud? Yeah. And, like, as I, like, solve more bugs, I think I find it easier to have the confidence that, like, I'm actually going to fix the bug. Like, no matter how weird it is. Like, right now at work, I have this bug that I don't really totally know why it is at all. And it's, like, quite complicated. And no one who I've talked to knows what it is either. But I still feel, like, totally confident that I can solve it and that, like, next week I'll probably have it totally figured out, right?
Optimism. Optimism is a job skill. Yeah.
Yeah.
Yeah, like, but there's always those ones that you can't reproduce or only happen once a week or involve, like, 6 computers and... Sorry.
No, totally. Like, even bugs with 6 computers that you can't reproduce that only happen once a week. Like, those 2 are bugs that you can solve.
It's true. It's true.
Well, in your blog, you say, be unreasonably confident in my ability to fix the bug. I liked that a lot because, it's so easy to be unreasonably unconfident.
Yeah. And you really need it, right? Because otherwise, like, it's kind of reasonable to give up when you have this, like, non-deterministic bug.
Yeah.
Yeah.
And somebody breathing down your neck saying, you got to ship it.
Right. And if there's a lot of time pressure, sometimes you have to, like, give up, and that's, like, a reasonable choice. But I still try to hold on to, like, the confidence that, like, if I had, like, a month, I could figure it out. Like, given, like, an unlimited amount of time, I can solve, like, unlimited things of unlimited complicatedness.
What else do you have in your how you got better at debugging?
I feel like I need to look at it to remember.
Yeah, it's always great when somebody starts asking you detailed questions about a blog you wrote like 6 months ago. And really, yes.
Oh, yeah. Okay, but now I have it. Oh, yeah. So one thing that really helps me is to remember that, like, there is logic behind why the bug is happening. I find this really hard sometimes because it's easy to just say like, oh, computers, they just do things, which is not true at all, right? Like computers are totally logical machines. And every time a bug happens, it's happening for like there were instructions that got executed and functions that got called with parameters, and like it's always totally logical and straight, and like even if it doesn't seem like that.
Yeah, there's several times a year where I have a bug and I look at it and my first thought is that is not possible. This can't actually be happening. Mm-hmm. And yet, of course, it's happening. It's a computer. It's logical.
Yeah. So trying to hold on to yeah, it's so really useful to remind myself that it is in fact happening.
And because I think it's impossible means that there's some assumption that I have that I need to let go of.
Yes. But like, I think that these two things, where you like believe that it's logical and like you have some confidence, are like not enough by themselves, even though like I kind of wish that they were. So like there's some bugs that I could solve now that like when I just finished undergrad I totally could not have ever solved, because now I know a lot more.
Knowledge is power.
Yeah. And that one's kind of hard for me to like grapple with, because I want to believe that like I can solve everything, but sometimes I'll like learn a new piece of information and I'm like, oh, well, I was never going to figure out that bug without that piece of information ever. Okay, good. Now I know it. Like, next thing.
Yeah, you always have to learn stuff.
Yeah.
By the way, when I said knowledge is power, Christopher rolled his eyes so hard that I think they came out and rolled across the floor. So, yeah, I didn't mean, it wasn't giggling at you. I was totally laughing at him. Let's see, you also suggest talking to other people, which I think is great, if only you talk to an inanimate object. I'm still a huge proponent of that, where you just explain the problem, and sometimes that is enough.
Yeah. Or sometimes they hold the like key to the kingdom, right, of the secret like missing knowledge that you're missing.
Well, the person who said, "Have you tried strace?"
Yeah, or the person who told me about strace.
All right. Well, I think those are good pieces of advice for debugging.
Also to like it.
That's a good one too. If you're in constant pain as you're trying to figure something out, it's really not. It makes it much harder than if you can let go of the angst and enjoy the puzzle. I mean,
well, sometimes you have to. Yeah, sometimes I get in the mindset that I'm a detective, and that's kind of a cool. Okay, what are the clues and but then you realize that you're probably the murderer, which makes it a little harder. So,
both murderer and detective. Yes, indeed. One of the other things you talked about in your PyCon talk was hacking the kernel. I'm not sure you fulfilled that promise. Did you talk about actually modifying the kernel?
Not in that talk, no. In a different talk, I talked about modifying the kernel.
I may have watched more than one talk, so I may have them confused. Yeah.
I gave this talk at Strangeloop in 2014 called "You Can Be a Kernel Hacker," where I talked about how like understanding the code in the Linux kernel is not actually like impossible. Which I think is a concept that's kind of like familiar to embedded programmers, right? Because you're used to like working with like the full stack of your program, and you're like, well, there's just code everywhere, and I could understand all of it, I imagine.
Sometimes we get to write all of the code ourselves, so we'd better understand it. Yes,
right. So like the code in the Linux kernel is just code that you can like read and look at, and which was kind of very surprising to me. Like I thought of it as like this like mystical thing, but it's not. And so when I started wanting to learn about the Linux kernel, I had this problem where I didn't know where to start or like how to approach like having fun with the Linux kernel. Because I was like, I'm not going to contribute to the Linux kernel because that's a lot of work, and it's like this like very intense process. But it turns out that you can write Linux kernel modules where you write your own code that like gets inserted into the kernel, and then you can have fun and play around there. And that's really easy to get started with. So I did a couple of fun things. One thing I did was I wrote like a rootkit where you like where you make like a backdoor into your kernel, where if you like look at the right file, then you suddenly become root. Which is like surprisingly, it's like a relatively easy like Linux kernel module project. And like to get it to work, you need to already be root on your system, like,
Right.
And then you can create an exploit so that anyone can become root, and then hopefully you remember to turn it off. So I did that, and then I wanted to give a talk about like writing Linux kernel modules, and then my friend had this hilarious idea to write a kernel module which every time you open a file, like an MP3 file, rickrolls you, so it plays like Rick Astley instead.
Never gonna give you up.
Which is also a pretty easy Linux kernel module to write, because you just need to like override the open system call so that whenever it opens an MP3 file, it just like sends you to Rick Astley instead. And it's really awesome to see, because you just like go into a music player and you start playing files and you can't play any music anymore.
Fun with other people's computers.
Yeah. And so like my friend came up with this idea, and I was preparing this talk, and then my partner actually wrote the kernel module, and he'd never written a Linux kernel module before, but he was just like, oh yeah, that sounds fun. I could do that.
Well, and it does sound fun, but you also could think if you were making a BeagleBone Black sort of widget, and every time you wanted to turn on some functionality, it was not working. Fine, write a kernel module. You don't have to send it out to the Linux people. We've all heard those are very mean people.
Only for me.
But you can write a kernel module, stick it in, and it will debug for you if strace doesn't work out.
Yeah. Yeah. And I really like this idea of like engaging with like software like independently of the community that develops it, if that makes sense. Like,
Yes.
You don't need to be like best friends with like Linux to like have fun with Linux, right?
Right. Well, and this idea is kind of foreign to a lot of developers, dynamically modifying the operating system as it's running seems like a crazy idea, or at least it does to me historically.
Yeah.
But it's not. I mean, it's a common thing now. You do it on Mac OS, you do it on Linux, and you can unload and load different functionality that extends the kernel, and you can do just about anything you want, which is kind of amazing.
Every time you plug in a new thumb drive.
Right.
Yeah.
All right, I only have a couple more questions because I think we're about out of time, and it's getting late for us. So I've heard you have a zine about strace, and I have a question about that. What is a zine?
So a zine is like it comes from the word fanzine. So it's sort of like a little magazine that you write yourself. Often like there's kind of this like photocopied hand-drawn aesthetic to it. It's often associated with like the Riot Girl movement in the 90s, and but it doesn't need to be about feminism. It can also be about computers. Like people will often make like fanzines about like bands they like or something. So I wrote a fanzine about strace and how much I love strace.
That is pretty cool. I don't think there are any Linux commands I love that much. On the other hand, there might be some microprocessors.
I would love it if you wrote a microprocessor zine. Oh my god.
Yeah. Well, how about how a quadcopter works? Because that one is coming. Christopher, do you have any more questions?
I had actually something I thought of back when we were talking about strace in detail, and I didn't manage to ask. So this seems like a great way to reverse engineer stuff, or at least get started reverse engineering stuff.
Yeah.
But I can see why some developers might not want it to be usable. Is there a way that somebody could block it out and say, no, you can't strace this executable? Or is it just, nope, that's just the way it works?
I don't see how. No. because you're asking, like when you're doing a system call, you're asking the operating system to do the system call for you. And when you use strace, you're like, hey, operating system, please report to me back what happened. So I can't imagine any way to do that, because it's not like you're not asking the program to tell you, you're asking the operating system.
Now I want to repurpose all the system calls. So I'm calling things that look like they do something, but actually do them in such a way that they do something else.
strace and kernel mods. You can have a really good time with these tools.
Yeah. Yeah. Okay. Well, that's what I figured, but it's interesting to hear that. Yeah.
Yeah. But there's another thing. So there's this environment variable called LD preload, where you can say, like, let's say there's an internal function in a program that you want to like rewrite or like spy on. So like you're trying to reverse engineer something and you see this like magic awesome function and you're like, what happens when you run the magic awesome function? You can kind of like write your own magic awesome function that wraps it and like tell the dynamic linker, like, hey, when you want to call the function in this program, call my function instead.
Oh my.
Yeah.
Like,
which is amazing.
Like the function that says check DRM.
Yeah, for instance.
You can just wrap that with never mind.
Yeah, exactly.
We won't talk about what I did to VxWorks once upon a time.
Yeah, let's not.
I really want to know.
I had an argument with the license server, so I might have done something to it.
That's awesome. Right. So LD preload is like a perfect, but there's this blog post that I read somewhere about how like you can try to protect yourself from LD preload, and then you can try to like circumvent the protection, and then you can try to like there's this like layer of like LD preload hacks and then like protections from LD preload hacks that went like fairly deep, and I don't remember who won in the end. Probably
no one.
Yeah, that is. Julia, do you have any last thoughts you'd like to leave us with?
I'm kind of left thinking that like people who aren't embedded developers probably have a lot to learn from embedded developers.
Oh, that's nice.
It probably goes both ways.
Yes, it definitely goes both ways.
One of the things I've been thinking about a lot lately is embedded programming has gotten a little ossified.
In spots. We're growing. We're learning. All right. My guest has been Julia Evans, software engineer at Stripe, focused on machine learning. Her blog is jvns.ca because she's Canadian. And her PyCon video about using operating system features for debugging will, of course, be in the show notes, or you can just search on YouTube. Thank you, Julia, for joining us.
Thanks so much for having me.
And thank you to Christopher for producing and co-hosting. And thank you for listening. We love it when you tell other people about our show. That is the nicest thing you can do for us. Although some of your emails are pretty nice too. If you'd like to contact us, hit the contact link on embedded.fm or email us show@embedded.fm. And now I have a final thought to leave you with. Now, I know you were all wondering who said it initially, so Abraham Maslow in Towards a Psychology of Being. I suppose it is tempting, if the only tool you have is a hammer, to treat everything as if it were a nail. Embedded FM is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive any revenue from them. At this time, our sole sponsor remains Logical Elegance.